What's up, y'all? I make cool graphs on Desmos, and I show people on TikTok, and I want to show you guys here how to make them. So let's start with my most recent one. So let's come back over to here, and let's just watch it just to
I
get a feel
made
for it.
this, but I was having trouble finding any ellipse. So I had to go back to the comment, and I realized we were only supposed to look at the apexes. So, if you turn that off, there's the ellipse.
That was pretty
I
cool.
made this.
Super happy with that one. So let's talk about how to make it. Let's make it together. Now let's make it a little prettier, a little better than we did last time. So first off, we're going to kind of establish that we're going to need a Vx, not a capital X though. Vx equals, and we're going to need a Vy. Vy equals. V sub y equals. Okay. Then, because we're going to have our main velocity, so we're going to put it on a slider. We'll start with our main velocity being 10. And we're going to do our classic physics stuff. So we're going to say that the y is v sine of our angle, which we're going to call q, and that our vx is v cosine of our angle, which we're going to call q. And then we don't actually need these graphs. And then the last thing we need for the position is our acceleration. So we'll start with negative 9.8. Then we'll think about what happens if it's something else. So we're gonna use a parametric. We got the x position and we got the y position. So we have the velocity even for x. So to get the position, we have to take the integral. And it's not the integral with respect to q, so we're not making that cosine sine. It's the integral with respect to t. So we just got to toss a t on there. So we can do it real pretty and just do v sub x t. And that's all there is to it. And then for the y, we're going to do a similar thing, but there is an acceleration on the y. Because that's what the a is, just the y acceleration, like due to gravity. So we're going to do the classic a over 2 t squared, and then plus that initial y velocity times t, and there's no real initial position, so we don't need to worry about that. So then we're looking at this, and we can use this slider to show all of those possible trajectories. Of course, we just want to show them all at the same time. So the way we're going to do that is just make a list from 1 to 180. And there you see we got a bunch of them. Oh, why is it stopping though? It's just stopping because we don't have our t going very far. If we did our t like 5, we'd be able to see the paths down. Alright, so yeah, this is just a parametric equation. It's defining the x coordinates and it's defining the y coordinates. And if you know physics, you've really already done this before. You got your y velocity, you've got your x velocity. There's no acceleration on the x because there's no gravity. So this is nice to show all those. We want to make a slight adjustment so that we can just change how many we have. So we're going to make this go up to n. And then to readjust it, we'll do that times 180 divided by n. And then they don't like that, so we'll put a little multiplication sign there. And then we'll add a slider for n. So see, now we can let's go back to some degrees. So we want to make that step 1, and then make it go from 0 to I guess 180 for now. And yeah, there we go. So we got all of them. We're only throwing them up. We're not throwing them sideways. So yeah, that's a beautiful thing. Maybe we should have that then go from 1 to 79. Well, it doesn't matter anyway because we're going to set those. Like, for example, we'll do or should I just make this 79? It really doesn't make a difference. Let's keep that at 180. So then we can adjust how many there are. That's nice. Let's keep it low for now. So we got that. But then the whole deal... Well, then let's do the points, the actual point. So to do that, you see how it's just going from 0 to t. and the end of it is just whatever t currently is. But so what we do, we make this like a time. Can we do? We don't want t, so that's why we usually do a for it. Let's do like, we'll do t1. This will be our go button. So we'll do t1 equals, and then we'll do this up to t1. So you see what that'll do. What? Oh, let me get rid of that. So you see what this does, right? We gotta get rid of this one. This makes it expand out. So then what we can do is, instead of having this one from 0 to t, have this to t1. And so now that's just a set of points it should be at the ends of those lines. So those are like the actual balls that are the projectiles. And then what we did to turn it off, what did we do to turn it off? What we did to turn it off is, well, first off, I duplicated this one again. And then I had to do a little piecewise deal. So I put this in the curly brackets right here. And I said, I only want to actually do that if the derivative of the y is greater than 0. So I just kind of myself took the derivative. So I said 2a t1 is, or no, t, I think t plus v sub y is greater than 0. Yeah. And that really does it right there. Yeah. I mean, just for cleanliness, I think just to make myself more comfortable, I should put it on this one too. But that really does it right there. See, I'm just taking the derivative of the y's, and I'm saying only do that if the derivative of the y's is positive. So that means right when it turns around, that's where it's going to stop. Except for that's not what it's doing now, is it? It's not waiting until it turns around. Is this supposed to be T1? No. Then it's just a weird like pop thing probably. Yeah, nah, we don't want that. Nah. That should be T. That should be T. But look at the problem. When I turn this on, see, it's not at their apex. Why is that not at their apex? That worked last time. Because that's not a 2. Because there's no 2 here. The 2 cancels. There we go. So now that's our ellipse where the apexes are. That's how it is. Because when you bring the 2 to the front, it cancels with the over 2. Obviously, that 2 shouldn't actually be there. Alright, we're good now. And yeah, see, that's really what I did. And so now we can, yeah, there's our ellipse. You can change how many of them there are, how many balls there are. Make you really be able to see that ellipse strongly. You can change what the acceleration is. You can change what the initial velocity is. But there you go. That's pretty cool. That's how that works. So yeah, I think we're going to call it for that. So that's it, guys. I hope you learned something, And I hope you enjoyed yourself a little bit. If you got any more questions, put them in the comments below. And if you liked it, like the video, subscribe. You know, hopefully there's more coming. That would help me out a lot. So, peace, guys.